Hi, welcome to this lesson on Probability Counting Principles Part 1. Let's have a look at question 3. In a game of Among Us, there are 10 crew members on a ship. 3 are red, 2 are green, 4 are orange, and 1 is blue. So of these 10 members aboard, in how many ways can they be arranged next to each other if all members of the same color must stand next to each other? Okay, so there are 3 red members, there are 2 green members, there are 4 orange members, and there are 1 blue member. Okay, so of those 10 people, of those 4 unique colors, the sub-objects, there are 3 factorial ways of arranging the 3 red members, 2 factorial ways of arranging the 2 green members, 4 factorial ways of arranging the 4 orange members, and just 1 factorial way of arranging the blue member. So those are the ways that they can stand within their own group, and then members of the same color standing next to each other, there are 4 objects there are 4 factorial ways. So by the fundamental counting principle, there are 4 factorial times 3 factorial times 2 factorial times 4 factorial times 1 factorial ways. So if we pull up our calculator, let's check what that is. So we have 4 factorial times 3 factorial times 2 factorial times 4 factorial. Okay, and then 1 factorial is just 1, but we can just write there 1 factorial. Okay, and then that is 6,912 different ways that those 10 crew members can stand next to each other, such that all members of the same color are always standing next to each other. What if the 2 green members must be at the start and the end of the line? Okay, so now there are 10 spaces in which those 10 members can stand next to each other, but there can either be the first green member and then the second green member standing next to each other, or of those same 10 ways, the second green member can stand first and the first green member can stand at the end of the line. So there are 2 possibilities here. That's the first possibility, and this is the second possibility. Now, there are 8 ways here. There are 8 objects, in this case, the 8 crew members of the other colors, the 3 red, the 4 orange, and the 1 blue. So because they don't have to stand in any specific order, there are 8 factorial ways of arranging those 2 objects. So there are 2 objects times the 8 factorial ways. Okay, and that is equal to what? Let's check on our calculator. Okay, so that is going to be 2 times 8 factorial, which is 80,640 ways. Okay, so that's much bigger than the first way. The first way had a lot more restrictions because all colors need to stand next to each other. And then here, only the green members had to stand at the start and end of the line. Okay, so there were fewer restrictions, meaning more possibilities. Lastly, what if 1 green and 1 orange member are both eliminated? Then how many ways can we now arrange these crew members? So now 1 of the green are gone, so there's only 1 green left. Okay, 1 orange member is gone, so there's only 3 orange members left. There are still 3 red members, and there are still 1 blue member. So essentially, you can think of this in terms of the game, that green and orange were voted off the ship. Okay, so they were eliminated from the crew. Okay, so now how many are there? There's 3, 3, 6, 1 is 7, 1 is 8. So there are 8 members left. So how can they be arranged? Well, there was no other restrictions. So that means there are 8 factorial ways of arranging them. So let's check what 8 factorial ways are. So that's going to be 8 factorial, and it's equal to 40,320 different ways. So if those 2 crewmates are eliminated from the game, then there are 40,320 ways we can still arrange the other 8 crew members next to each other. All right, so that's how we would do this type of question. I'll see you in the next one.